You know the way most of us use Java Enums? It's kind of like owning a smartphone and only ever using it to make phone calls. I mean, sure, it works, but you are missing out on so much power that's sitting right there under the hood. So in this explainer, we're going to peel back the layers and I'll show you how to turn your enums from just simple lists into really powerful, intelligent objects. Let's get into it. So here's our game plan. We're going to start with the basics everyone knows, then we'll uncover the secret that gives enums all their power. And from there, we'll learn how to add state and behavior, really turning them into powerful tools for your code.
All right, first things first. Let's start on some familiar ground with the classic everyday enum that you've probably written 1,000 times before. And this is it, right? The humble enum. It's a clean, super type-safe way to represent a fixed set of constants. Running, pending, failed. Simple, reliable, and honestly, for a lot of people, this is where the story ends. But it's really just the beginning.
So it's time to pull back the curtain a little bit. Have you ever really stopped to wonder where an enum gets all its built-in abilities? Like, what's actually going on behind this simple keyword?
I mean, think about it. You type status.values and poof, you get a list of all the constants. You use .ordinal, you get their position. These methods are just there. But come on, this is programming, right? Nothing just appears out of thin air. So where are they coming from? Well, we don't have to guess. We can actually investigate this ourselves. We can ask our simple little enum a pretty deep question. Hey, what are you really?
And boom, there it is, the big secret, hiding in plain sight this whole time. Every single enum you create in Java, no matter how simple, implicitly extends a special class called java.lang.Enum. So this enum superclass, that's the source of all the magic. Methods like values, ordinal, name, they're all inherited from this hidden parent. It was Java's really elegant way to solve an old problem, to stop all the bugs and confusion that came from using, just random numbers or strings as constants. Okay, so here's the huge takeaway. If an enum is secretly a class, well, can it do class-like things? Absolutely. Now that we know their secret identity, let's unlock the most powerful feature this gives us, the ability for our enums to hold their own data. Let's switch to a new example to see how this works. We've got a simple enum of laptop models. Right now, they're just names. But what if we wanted each of these constants to know its own price?
A totally natural first try might look something like this, right? You just add the price in parentheses next to the name. But the compiler immediately freaks out. It sees that number, but it has no idea what to do with it. We're missing a couple of key pieces. First things first, we need a place, like a little box, to store the price. So just like in any regular class, we add a private instance variable. But that doesn't solve our main problem. We still have no way to get the number 2000 from the declaration into that price variable. And that brings us to the real key that unlocks this entire feature, constructors. The exact same tool we use to initialize regular objects is what we need right here. So let's think about this. We have a value, 2000, and we have a variable, price. What's the standard Java way to get an initial value into an instance variable when an object is first being created? It's a constructor. The moment we add this private constructor, we've created a channel. Now, that line, MacBook 2000, is no longer just decoration. It's an actual call to this constructor. The Java virtual machine sees it, creates the MacBook object, passes 2000 into the constructor, and that value gets assigned to the price variable. And just like that, the error is gone. And this is probably the most important concept to really let sink in. MacBook, XPS, and Surface are not just names on a list anymore. They are distinct, fully fledged objects. Each one is a unique instance of the laptop enum, created once with its own personal data.
Okay, that's pretty cool, right? We've built this awesome stateful enum, but how do we actually put it to work? Let's bring it all together and see this thing in action.
So just like any well-designed class, we need a safe way to access our private price variable. We do that by adding a simple public getter method. Now, this is our first piece of custom behavior, but we could add anything we want here. Maybe a method called isPremium that returns true if the price is over a certain amount. The possibilities are endless. Now let's put it all together. First, we use that familiar .values method to get an array of all our laptop objects. Then, we can just loop through that array. And here is the real magic. Inside the loop, each lap isn't just a name, it's a full object. That means we can call our custom getPrice method on it to access its own unique price.
And this is the result. A beautiful, clean output where we've gone through our fixed set of constants and pulled out the custom data we attach to each one. We've basically created a tiny, safe, in-memory database. Pretty powerful stuff.
So let's just recap this amazing transformation. We started with a basic enum, which is really just a simple list of names. And we turned it into a class-like enum, which is a fixed set of real objects. We went from having no state at all to a world where each constant has its own data. And we evolved from only having default methods to being able to add any custom behavior we could possibly need. So let's lock in the most important points. First, remember that enums are secretly special kinds of classes. Because of that, they can hold their own data using instance variables. Those variables get their values from a private constructor that's called for each constant. And finally, you can add your own methods to give them custom behavior. And I'll just leave you with this final thought. We've clearly established that enums are way more class-like than they appear on the surface. So what else can they do? Could an enum, for instance, implement an interface? That's a great question for you to explore on your own. Thanks for watching.